There is a structure off the northeastern coast of Australia that is the largest thing any living creature has ever built on the surface of the Earth. It stretches for 2,300 kilometres along the Queensland coast, from the tip of Cape York Peninsula in the north to the Bunker Group of Islands in the south. It covers an area of approximately 344,000 square kilometres, larger than the United Kingdom, larger than Italy, larger than Japan. It contains approximately 3,000 individual reef systems and 900 islands. It is home to more than 1,500 species of fish, 4,000 species of mollusk, 240 species of bird, 30 species of whale and dolphin, 6 of the world's 7 species of marine turtle, and coral species so numerous and so varied that marine biologists are still discovering new ones. It is the Great Barrier Reef, the largest coral reef system in the world. The largest structure built by living organisms in the entire history of the planet. And it is so vast that it is visible from space, a pale blue-green shadow along the Queensland coast, the accumulated biological achievement of 25 million years of coral polyps building their calcium carbonate skeletons one generation on top of another in the warm shallow waters of the Coral Sea. It nearly killed James Cook on a June night in 1770. The story of the Great Barrier Reef, of what it is, how it came to be, how it was encountered by the European navigators who mapped the Australian coast, and what has happened to it in the 2.5 centuries since Cook's endeavour struck its coral in one of the most dramatic near-disasters in the history of Pacific navigation, is one of the most extraordinary stories in the entire intersection of natural history and human exploration. It is a story about the relationship between the living world and the human world, about the specific beauty and the specific danger of a structure so large and so complex that no single mind can fully comprehend it, and about the urgent contemporary reality that the largest living structure on Earth is dying, not from the impact of a ship's hull but from the accumulated effect of the industrial civilization that has been warming the planet's oceans for 2 centuries. Before the Europeans. Before Cook. Before any human being set eyes on the reef from a ship. The Great Barrier Reef had been known to the Aboriginal and Torres Strait Islander peoples of northeastern Australia for tens of thousands of years, not as a navigational hazard, as it would become to European sailors, but as a living world of extraordinary richness that provided food and cultural significance and the specific knowledge that comes from tens of thousands of years of direct relationship with a place. The Torres Strait Islander peoples, the communities of the islands between Australia and New Guinea whose maritime culture was built entirely around the sea and its resources, had the most intimate knowledge of the reef of any human community. Their canoes navigated the reef passages with the specific confidence of people who had been doing so for generations, whose knowledge of the reef's geography was encoded in the same tradition of story and ceremony and practical navigation skill that Aboriginal land knowledge was encoded in on the mainland. The reef was not a barrier to them. It was home. The specific ecological knowledge that Torres Strait Islander and Aboriginal coastal communities had developed over thousands of years of reef interaction, knowing where the fish aggregated and in what season, knowing which passages were navigable and which were not, knowing the specific behavior of the tides and the currents that the reef system generated, was the kind of knowledge that European navigators arriving from outside the system were almost entirely without. The catastrophic consequences of this knowledge gap, for Cook in 1770, and for the numerous other ships that came to grief on the reef in the subsequent century of Australian coastal navigation, were the direct result of the specific asymmetry between indigenous knowledge accumulated over millennia and European knowledge accumulated over weeks. The reef itself, the physical structure, the accumulated biological achievement of 25 million years, began forming in approximately its current location when the Australian continent drifted to its present position in the tropical latitudes, and the shallow continental shelf off the Queensland coast provided the combination of warm water and sunlight and calcium carbonate availability that coral needs to grow. The current reef structure is approximately 8,000 years old in its living form. The reef was killed during the last ice age when sea levels dropped and the reef was exposed to the air, and regrew as sea levels rose following the ice age's end. The 25 million year figure refers to the age of the reef province, the geological history of coral reef formation in the region, rather than the current reef structure. The coral polyps that build the reef are tiny animals, most are less than a centimeter in diameter, that extract calcium carbonate from the seawater and build the hard external skeleton that constitutes the reef structure. They live in symbiosis with microscopic algae called zooxanthellae that live within their tissues and provide the photosynthetic energy that the polyp needs to grow and calcify. The color of living coral, the extraordinary range of browns and greens and yellows and oranges that make a healthy reef one of the most visually spectacular environments on Earth, comes primarily from these zooxanthellae. When the water temperature rises above the coral's tolerance threshold, even by 1 or 2 degrees Celsius, the zooxanthellae are expelled and the coral bleaches white, losing the energy source it needs to survive. If the temperature stress is brief, the coral can recover. If it persists, the coral dies. This biological vulnerability, the specific fragility of the relationship between coral and zooxanthellae that has been stable for millions of years, is the mechanism by which climate change is killing the Great Barrier Reef. But that is the end of the story, not the beginning. The beginning is the reef itself, the living world that Cook encountered on that June night in 1770. James Cook was the greatest navigator of the age of sail. The farmer's son from Marton in Yorkshire who had taught himself mathematics and navigation and seamanship through a combination of natural genius and relentless application, who had surveyed the St. Lawrence River in Canada with a precision that astonished the Royal Navy, who had mapped Newfoundland with a thoroughness that established his reputation as the finest hydrographic surveyor of his generation. Cook was not someone who ran his ship onto reefs through carelessness or incompetence. The fact that he ran the Endeavour onto the Great Barrier Reef on the night of June 11, 1770, tells you everything you need to know about the specific nature of the danger that the reef presents to navigators who do not know it. He had been sailing up the eastern Australian coast for approximately 8 weeks when the disaster struck. The coast had been encouraging a consistent succession of bays and headlands and the gradual accumulation of the geographical knowledge that his charts were preserving with the specific precision of a surveyor who understood that the maps he was making would guide every subsequent navigator in these waters. The sea had been relatively clear. The water had been deep enough to navigate safely. He had not yet fully understood that he was inside the reef system, that the coast he was mapping lay behind a barrier of coral that extended for hundreds of kilometers to the east, and that the water between the coast and the reef, while generally navigable, contained individual coral outcrops and shallow sections that were invisible in the dark. The night of June 11, 1770 was clear. The moon was almost full. The Endeavour was making about 4 knots through water that the leadsman had been checking regularly and finding adequate depth. Cook had reduced sail for the night, standard practice, and had gone below. The watch officer had no reason to expect danger. At 23 minutes before 11 o'clock at night, the Endeavour struck. The specific physical sensation of a wooden sailing ship hitting a coral reef at speed has been described by the survivors of numerous such accidents: a sudden violent shuddering, the sound of coral grinding against timber, the immediate flood of water into the bilges, and the specific terrifying realization of people who understand ships that they are now in a situation where everything depends on what happens in the next few minutes. Cook was on deck in seconds. The assessment was immediate and professional. The ship was firmly aground on a coral head, the tide was ebbing, which meant the ship was settling rather than floating off, and the structural damage to the hull was uncertain, but the rate of ingress of water into the bilges was worryingly fast. He ordered the anchors put out astern, to give the ship something to heave against when the tide returned, and began the systematic lightening of the ship that was the standard response to grounding, throwing overboard everything that could be spared. Ballast, stores, water casks, the ship's guns, 6 heavy iron cannon going over the side into the Coral Sea, their loss a significant military and commercial cost, their absence a necessary condition for getting the ship off the reef. The pumps were manned continuously. 3 pumps working around the clock to keep pace with the water coming in through whatever damage the coral had done to the hull. The men worked in shifts, the exhaustion of continuous pumping adding to the specific psychological stress of knowing that they were aground on a reef in the middle of an ocean, thousands of miles from any port that could repair them, with a damaged hull and no certainty that the ship would float even if they got it off the coral. For 23 hours the Endeavour sat on the reef. The tide came back in the following day, June 12, and the combined effect of the anchors and the lightened ship's buoyancy allowed the crew to begin heaving the ship off the coral with the windlass. At approximately 10:20 at night on June 12, 23 hours after striking, the Endeavour came off the reef, and immediately began sinking faster. The coral head that had held the ship had also, as sometimes happens with wooden ships on coral, been plugging part of the hole it had made. With the coral no longer in contact with the hull, the rate of water ingress increased dramatically. The pumps were barely keeping up. The ship was floating but filling, and the nearest land was still some distance to the west. The fothering, the technique of drawing a sail stuffed with oakum and wool and dung under the hull to be sucked into the damaged area by the inflow of water, partially plugging the leak, was the innovation that saved the Endeavour and everyone aboard it. The technique was known but rarely used, and it worked well enough to reduce the rate of ingress to something the pumps could manage. Cook sailed the limping ship to the mouth of a river on the Queensland coast, the Endeavour River, now the site of Cooktown, and beached it for 7 weeks of repairs. Those 7 weeks were, paradoxically, the most scientifically productive period of the entire Australian coast survey. The botanist Joseph Banks and his team had unlimited time ashore to collect and observe, and the collections they made in the Cooktown area, the Queensland tropical forest environment producing specimens of extraordinary novelty and biological significance, were among the most important of the entire voyage. It was here that Banks first encountered the kangaroo, observing it from a distance, eventually obtaining a specimen, and sending back to Europe the description of an animal so improbable that the first European audiences who heard about it assumed that someone was joking. The name Banks gave to the bay where the botanical abundance had first impressed him, Botany Bay, further south, where the Endeavour had made its first extended landing on the Australian coast, became the most famous place name in the early history of European Australia, eventually chosen as the site for the first British settlement and synonymous in the British imagination with the penal transportation system that it generated. The specific scientific legacy of Cook's Barrier Reef encounter was the knowledge it produced about the existence and extent of the reef system itself. Cook spent the remainder of his time on the Australian coast navigating the inner passage between the reef and the mainland, a navigation of extraordinary difficulty and anxiety, as the charts he was making were the first such charts, every observation adding information that had not previously existed in European navigation. He eventually found a passage through the outer reef to the open ocean. Providential Channel, he called it, in the specific thankfulness of a navigator who has found a way out of an enclosed sea and escaped to the north. His charts of the Great Barrier Reef were the foundation of all subsequent European navigation in the region. The first documentation of the reef's existence, extent, and approximate geography, produced under the specific navigational stress of someone who had already been nearly destroyed by the thing he was charting. The subsequent European history of the Great Barrier Reef was primarily a history of ships, of the vessels that navigated the inner passage to service the growing colonial settlements of Queensland, of the ones that did not make it, of the gradual accumulation of chart data that made the passage progressively safer without ever making it entirely safe. The Torres Strait, at the northern end of the reef, was the critical gateway for ships sailing between the Pacific and Indian Oceans, and its navigation was the specific challenge that the colonial maritime world addressed through progressively better charts and navigational aids. The scientific investigation of the reef, the biological study of what the reef actually was and what it contained, began seriously in the 19th century and reached its first major synthesis with the work of the naturalists who accompanied the various scientific expeditions to the Queensland coast in the Victorian era. The understanding that coral reefs were built by living organisms rather than being geological formations was established early in the 19th century, and the specific mechanism of coral growth and the relationship between coral and zooxanthellae was worked out progressively over the following decades. The reef was declared a marine park in 1975, the Great Barrier Reef Marine Park, managed by the Australian government as one of the world's largest protected marine areas. It was designated a UNESCO World Heritage Site in 1981, recognized as one of the outstanding natural values on Earth, its biological diversity and its ecological significance placing it in the company of the Galapagos Islands and the Serengeti and the Amazon rainforest as one of the irreplaceable natural treasures of the planet. And then the bleaching began. The first mass bleaching event on the Great Barrier Reef was recorded in 1998. Triggered by an El Niño event that raised ocean temperatures above coral tolerance thresholds across large areas of the reef. It was the worst bleaching event the reef had experienced in recorded history. Approximately 16% of the world's coral reefs died that year. The bleaching events have continued and accelerated. 2002, 2016, 2017, 2020, 2022. The 2016 bleaching event, Triggered by the marine heat wave of the 2015 to 2016 El Niño, the strongest El Niño in recorded history, killed approximately 50% of the coral in the northern third of the Great Barrier Reef in a single event. The northern reef, the most pristine section, the least affected by the agricultural runoff and the coastal development that affected the southern sections, was the section most severely damaged, because it was the section most directly in the path of the marine heat wave. The scientific consensus is clear and is not seriously disputed. The Great Barrier Reef is dying. Not quickly. Coral reefs are resilient, they can recover from bleaching events if given enough time and if the stresses are not too severe and too frequent. But the bleaching events are becoming more frequent and more severe as ocean temperatures rise, and the intervals between events are shortening faster than the coral can recover. The reef that Cook nearly died on in 1770, the reef that the Torres Strait Islander people had been living alongside for thousands of years, is losing its coral cover at a rate that the marine biologists who study it find increasingly alarming. The specific tragedy of the Great Barrier Reef is the tragedy of something too large and too beautiful and too important to fully comprehend until it begins to disappear. The reef that is visible from space, the largest living structure on Earth, the accumulated biological achievement of 25 million years, is being destroyed by the accumulated atmospheric effect of 2 centuries of industrial activity that the people doing the destroying were largely unaware of until the damage was already severe. Cook's endeavor struck the reef in the dark because he did not know the reef was there. The industrial civilization that is bleaching it is doing something in many ways more troubling. It knows the reef is there, knows what is happening to it, knows why, and knows what would need to change to save it, and continues on its course. The coral polyps are still building. Tiny. Patient. One skeleton at a time. The question is whether the world will give them the conditions they need to continue.